Alright class, so last time we talked about GC, gas chromatography. And if you remember, we went over how GC works and what type of information you can get out of it. There were two types of information you could get out of it. How many compounds you have in your mixture and the percent composition of each one. Let's say I have a sample, it's a mixture, I don't know anything about it. I'm going to run it through GC and then GC is going to give me 2 peaks and then the percentages are 70 to 30%. So I know my mixture had 2 compounds in it and the percent composition was 70 to 30%, for example. So GC gives you 2 pieces of information, how many compounds you have in your mixture and the percent composition of each one. Now, last time I showed you a sample GC graph, and the last thing I left you with, I said to be able to get good numbers from GC, you have to apply correction factor. To get accurate number from GC, we need to apply correction factor. And today we're going to go over how to apply the correction factor and why we need a correction factor. Now, the reason that you need a correction factor is because GC is very sensitive. So you have to apply a correction factor to be able to directly compare quantities. Let's take a step back to see what I mean by all this. So remember, you have a mixture in this experiment, right? You have a mixture and your mixture has 2 alcohol in it. And the key is the 2 alcohol are unknown. So you don't know what those 2 alcohols are. So you have a mixture. All you know is that your mixture has 2 alcohols in it. You don't know what those 2 alcohols are. Those are unknown to you. And you don't know the percentage of each alcohol in there. Yeah, so far so good? Okay. So the first thing that we need to do, what we are going to do, we are going to inject a reference sample. So before we're going to inject your mixture, which has 2 alcohols in it, you don't know what those are, you don't know the percentage of it, we are going to inject a reference sample. Now, what is the deal about this reference sample? Now, here's the thing about this reference sample. It has all the suspected unknown in it. It has all the suspected unknown. Now, what that means is it's got 5 unknown alcohol. It's got 5 unknown alcohol. And yours is 2 of these. Take a step back again. So before you're going to inject your mixture, we're going to inject a reference sample. This reference sample has 5 alcohol in it. Yours is 2 of these 5 alcohol. You don't know what your 2 alcohols are, but yours is 2 of these 5 alcohols. We're good so far? Okay. Now, this reference sample, I'm also going to call it a standard mixture. And one more time, this standard mixture that we're gonna inject first, it has 5 alcohol in it. It has 5 alcohol in it, and yours are 2 of those 5 alcohol. Also, this is key. This standard mixture has equal volume of all the alcohols. It has an equal volume of all the alcohols. And that's key. Because remember what we said? We said that GC is very sensitive. We need to apply a correction factor so we can directly compare the quantities. Now, when I inject a reference sample, a standard mixture, my mixture has 5 alcohol in it, yours is 2 of those, and then and in this mixture I have equal volume of all the alcohol. So I know what the percent composition is supposed to be. So I can figure out a correction factor and apply it to my sample. Because I know these are all equal volume, so I know they all have the same composition. So now I can figure out the correction factor and apply it to our mixture. Yeah? Okay. So the first thing we're going to do, we're going to inject the reference sample. We're going to inject our standard mixture. And when we inject the reference sample, we are going to get a GC graph. And every time you have a GC graph, when you look at the bottom of the GC graph, you will find a table that has retention time and it has area percent. All right, so we injected our standard mixture, our reference sample, and this is what the GC gave me. And these are the table. This is a table that goes with it. When I look at this, the first thing that I say, I go, okay, so the first line, that is the solvent. I can ignore that one. After that, let's count 1, 2, 3, 4, 5. So GC shows that we had 5 compounds in this mixture. That is great because that is what I expected. Because if you remember, we said that our standard mixture, our reference sample that we are going to inject first is going to have 5 alcohol and they are going to have equal volume of each. So 1, 2, 3, 4, 5. That's great. Here's my reference and the GC showed me that I have 5 compounds in this mixture and that's what I expected. So far so good? Okay. Then what we're going to do, we are going to inject your mixture. And you're going to get a GC graph that looks like this. And again, at the bottom of each GC graph, you're going to find retention time and area percent. When you look at this, you go to the first line, that's my solvent. Now, after that, you have 1, 2. So you have 2 compounds in your mixture. That's good because that's what you expected, right? Because we said you're going to have 2 unknown alcohol in your mixture. So it's kind of comforting that I run the GC on my mixture and I get 2 lines. So the GC tells me that I have 2 compounds in my mixture. Now, if you run the GC and you get a bunch of lines here, that means you probably contaminated the sample. But you see here, it says you have 2 compounds. So far, so good. Now, I want you to look at here. Remember what we said. We said the reference sample is going to have the 5 possible unknowns. And your mixture has 2 of these alcohols. I want to repeat this again to make sure that we are on the same page. So what we said that the reference sample has the 5 possible unknowns. It has the 5 possible unknowns. And yours is 2 of these. You have 2 of these alcohols. Now, let's match them up to see which 2 alcohols you have. So when I look at here, I have an alcohol retention time 1.572 and an alcohol retention time 4.40. So if I come over here and I try to match it up to these, I see that I probably have alcohol number 1 and alcohol number 5. So I probably have alcohol number 1 and alcohol number 5 because the retention time matches up. Now, this one is 4.440. This one is 4.436. This one is 1.572. This one is 1.579. They're slightly different. And that's kind of expected because GC is very sensitive. You inject in this at different times. There are different injection. So there are different parameters. And because of that, you expect these values to be slightly different, but they're still very, very close to each other. Okay. All right. Again, every time you change a little bit, GC is very sensitive, your values might change a little bit. So I know that my mixture has alcohol number 1 and alcohol number 5 because those are the two retention time that matched up pretty nicely. And one more time, these are the 5 possible unknown, and you have 2 of these. And we know we have alcohol 1 and we have alcohol number 5. Now what we need to do, we need to figure out the correction factor. And like we said, GC is very sensitive. So we have to apply a correction factor so we can directly compare the quantities. Now I want you to look at here. If you remember, we said for the reference, we have 5 alcohol of equal volume. So if you have 5 alcohol and you have an equal volume of each, then you would expect the area percent to be exactly the same for all of them, wouldn't you? You would, right? Because again, since we made the sample, we make sure that we have equal volume of each alcohol, so they have the same percent composition. So you would expect to get the same area percent, but that's not what we see. And this is why that we have to apply a correction factor. This is why we have to apply a correction factor, because we know these are all supposed to be the same percent composition, but that's not what we see here. So let's apply the correction factor. And this is why we have the reference, because we make the sample ourselves. We make sure that all the percent composition are the same, they're equal volume, and then when we don't get the same area percent, we can apply a correction. All right, ready to do the correction? Let's do the correction. To do the correction, what you do, you pick one of these peaks, okay? Doesn't matter which one you pick, you're going to pick one. Let's all pick reference number 2. Let's pick the second alcohol. So we're going to pick one. Doesn't matter which one we pick, but to all be consistent, let's pick the second one. Then the way to figure out the correction factor, what you are going to do, you are going to divide area percent for peak 2 over area percent for each alcohol. Now, what do I mean by that? Let's do it. So the correction factor for the alcohol 1 would be the area percent for peak 2, which is 0.3660 over 0.37520. So let's do for all of them. So this one would be 0.3660 over 0.37520. The second one again, for all of them, the pick that we picked, I can't talk and write at the same time. So the one that we picked as a reference, the area percent for that one goes on top, and we divide it by the area percent for each alcohol. Okay, hopefully you guys are following me. I'm just going to write them down. Then I'm going to go and grab my calculator. And then 0.3360 is area percent for peak 2, which we decided that's going to be our reference. Alright, you have your calculator. Let's figure this out together. Divided by 0.37520. For the first one, what I get is, I get 0.97548. The second one, 0.3360 divided by 0.3360, that's just 1. That makes it easy. The next one, 0.3360 divided by 0.35300. When we do that, I get 0.95184. Okay, for next one, 0.3360 divided by 0.44716. I get 0.75140. And for last one, I get 1.0161. Okay, hopefully I used my calculator correctly. We're good so far? Alright, so these are the correction factors that we got. Now let's go to our two alcohols. So we said that we have alcohol 1 and we have alcohol 5. If I come over here for alcohol 1, the correction factor is 0.97548. 0.97548. And then for alcohol 5, the correction factor is 1.0161. 1.0161. So these are the correction factors. We're good so far? Okay. Now what you're going to do, you're going to take the area percent and you are going to multiply it by the correction factor. Okay. So take the area percent and you're going to multiply it by the correction factor. Now, when you do that, let's do that and say what we get. I get 1.1603 for the first one and 0.3241 for the second one. Alright, so now what would you call this? Now what these are, what I'm going to call this, I'm going to call this corrected area percent. So I'm going to call this too, I want to call them corrected area percent. I like that name. So the area percent has been corrected. Now, I know I'm probably repeating myself, but let me just go over this one more time to make sure that you are really, really good. Now, remember again, in this case, the reference sample, we knew we had 5 alcohol of equal volume. So they had the same percent composition because it was an equal volume. Now, when we ran the GC, we got 5 peaks. Whoosh, that's really good. But when we look at area percent, they have different percentage, and that should not be it because we knew when we made the sample that all of these have exactly the same volume, they have the same percent composition. So we know now that this is not correct and that we need to apply a correction factor. Again, you pick one of these, doesn't matter which one you did. We did peak 2 as our reference, and then you applied the correction factor. It will be the area percent for that peak over the area percent for each one. We got the correction factor. In our sample, our alcohol was 1 and 5. We took the correction factor from alcohol 1 and 5, and you multiply with the area percent, and you get the corrected area percent. You get the corrected area percent. Okay, now what we're going to do, and again, we did all this to get to this point. Remember, now what you are trying to figure out, you're trying to figure out the percent composition of your alcohol, because you know you have alcohol 1 and 5. You want to know how much of alcohol 1 do you have, how much of alcohol 5 do you have. Is it 50-50%? Is it 40-60%? How are you going to do that? Now, we talked about this before. To figure out the percent composition, what you would do the area percent for peak A, which would be alcohol 1, over the area percent for peak A plus B, which would be alcohol 1 plus alcohol 5, times 100%. That gives you the percent composition. So far so good. And for B, you could just do percent area B over area A plus B, or subtract from 100 because we know we only have two things. Now, the way we do this, we're going to use the corrected area to be able to do this and get good numbers. Ready to do this? Let's do this one. So our alcohol 1, the corrected area percent was 1.1630 over 1.1603 plus, okay, you add them together, 0.32413 times 100%. Okay, put in your calculator, tell me what you get. What I get is 78.164. I did 560 throughout percent. I'm going to have alcohol 1. Okay. Now, you can do the same thing for alcohol 5, but I also know they only have two things, so I can just subtract them from each other, from 100, and that would give me. But let's not do that. Let's actually do the next one too. So the alcohol 2 would be 0.32413 over 1.1603 plus 0.32413 times 100%. I get 21.836%. That is my alcohol 5. Again, if you add them up together, they should end up to 100 because your mixture had nothing but these two. Yeah? Okay. Hopefully, it was kind of hard to use my calculator and talk and write at the same time. I'm not that talented. So hopefully these numbers are correct when I was putting my calculator. If not, you get the idea of how to do this. So you can figure out the percentage of each alcohol in your sample. Yeah? Okay. Very nice job. Very nice job.